Welcome to Brain Vision.
So let's first start off by drawing this system. So we have four charges forming a square. We can make an origin point in the middle. And then we can draw our axes. So we can say that this is going to be A and this is going to be B. We can say it's passing through O, the origin. And then we can say C, we can put like a C here and a D here. And this is your axes for part C. Okay. And at this point, we can define a little bit more. We can say this is going to be L equals 0.4 meters. And then we can say this is a mass. And at this point, we can start. So M equals 0.200 kilograms is our given. And then they're asking us, okay, find the moment of inertia of the system. So in its base, moment of inertia equals the sum of the masses times their distance from the axis of rotation squared. And this is going to equal 4mr squared, considering that we have four masses and they're all have equal distance to the origin. So this would be this line right here would be considered r. And at this point, we can say that r is going to be equal to, due to Pythagoras' theorem, it's going to be 0.2 squared plus 0.2 squared. And this is going to equal 0.2828 meters. And we can then solve this. Okay. And so this is for the system. And then they're asking us to find the moment of inertia along line AB. So that would be a little bit simpler. And we can say I equals 4mr squared, except for now, r is going to be a little bit different. We can say 4.2. And then for r, it's just going to be 0.2 because that's how far away it would be. That's how far away each mass would be from the axes of rotation. And at this point, this is going to be equal to I equals 0.032 kilograms meters squared rather. And then we find along the diagonal. So along the diagonal, there's two masses here, but they lie on the axis of rotation. So for C, it's going to be even less because it's just going to be 2mr squared. And the distance from these two masses here, so for part C, the distance from this mass to the axis of rotation is r, and then from this mass to the axis of rotation is also r. And we're not counting for these masses because they lie on the axis of rotation. So we can say that this is going to be equal to 2.2828 squared, and I for part C is going to equal 0.032 kilogram meters squared. And so this would be for CD. This would be for AB. And this would be for your system. And that's the end of the solution. Thank you for watching.